Plotinus would call multiplicity or manifoldness. We see the number one implied in there. So many years pass. Neoplatonic philosophy has been perpetuated by universities through medieval times and the Renaissance. Mathematical ideas have developed. Matrices come up. Well, matrices have been around, but they will come up again. So Carl Gustav Jakob Jacobi in Germany, in the university in Berlin around the 1820s, receives a liberal arts education and is a student of the classics, and he loved mathematics. However, his philosophy teacher was Hegel. Hegel gave lectures on the history of philosophy while he was at Berlin. It is unclear and probably unlikely that Jacobi attended these lectures on the history of philosophy. These specific lectures, which we have the transcripts of now, we know that he talked specifically about Neoplatonism and Plotinus in particular. But since this was a liberal arts institution, he most likely, it is possible that he was exposed to these ideas of Plotinus, especially in particular on number. So that means that whether or not he received these classes, he was influenced in a similar way that I would be influenced as a student to be acquainted with these kinds of ideas, to explore the Neoplatonist philosophy of Plotinus. And he was the instructor of Jacobi, so perhaps he did talk about these things in particular. But whether or not, the Neoplatonist philosophy was certainly in the milieu, in the background, as one of the historians I talked to in UD about this question asserted. He therefore was either positively, meaning he agreed with the Neoplatonist philosophy, or negatively influenced. But regardless of his personal views, we can demonstrate by example that these Neoplatonic notions of numeric unity are consistent with the kinds of mathematics that perhaps he was acquainted with, in particular matrices. The Jacobian matrix is a particular kind of matrix that he dealt with, that it's named after him at least. And so we see that Neoplatonic thought can simplify by ignoring the inner complexity of a matrix. So we can think of matrices, in particular square matrices, because these have their own set of operations. We can multiply and divide, and not divide, multiply and add matrices. So this simplified understanding could or could not have helped Jacobi, but the fact that it is consistent with the Neoplatonic idea and consistent with the actual practical mathematics shows that it at least isn't crazy to think that Neoplatonic notions about numeric unity are consistent with sound, more modern mathematics. This is 200 years ago. And so with square matrices, what is a square matrix? Square matrix is a matrix that has the same dimensions in rows as in columns. And so when you multiply the rows and columns, you get another matrix with the same number of rows and columns, if you kind of just take a step back, you can see how you can think of these as numbers. You have this thing A and this thing B multiplied together gets C. And then the identity matrix acts as 1, because 1 times the unit matrix, as it's called, the identity matrix, times any matrix is the matrix that you multiplied by the unit matrix. So we can see that this is a unit matrix. It has 1s along the diagonal. It's analogously equivalent to 1 in natural numbers. So we can see that the same properties of numbers, of the number 1 of numeric unity, is irreducibly simple, as complete, as indivisible, and as implied in other numbers can be true. It will be clearer in the example that follows. So this is intuitive, though. I mean, we understand very well what 1 means, and we can even expand that understanding to other objects that are not normally thought of as simple numbers. So why do we need to do this? Well, first of all, you don't need to. Presumably, I hope you are interested by this, but to strengthen the intuition, it helps to consider things that are intuitive deliberately in the conscious mind so that we can then consciously apply these to sort of non-intuitive applications that are more difficult. And this is precisely what growth is. So by attributing number to things that are non-numeric, we can make new connections in our minds and be able to expand our abilities in math to solve new problems. So some applied examples from Plotinus, something he might have dealt with is a number line. From Augustine, we're going to talk about multiplication, and for Jacobi, we're going to talk about matrix multiplication briefly. So we can see in a number line, Plotinus talks about this infinite line, and that's all good, but we see that it has unity. We see that it is a line. We can ascribe number to something that is totally non-numeric, a line. And we see that this line has units, that it is not truly one, as Augustine would say, but it is made up of smaller segments, smaller parts. And we can choose any part we like and say that is a unit. And we can ignore that unit's inner complexity. We can ignore the fact that an inch is so many millimeters. And so we see that this idea of irreducible simplicity is also consistent with this idea of line and also the completeness of a line and all these other things. So this abstract notion kind of checks out. And this multiplication is 1 times x is x. Augustine talks about, he says very simply, he has a more refined mathematical vocabulary. So instead of talking about these abstract forms that participate in these physical realities, he gives a more mathematically sound argument of any number times 1 is that number, and the double of a number is repeated addition, x plus x. And he says you can easily verify that if you have x plus 1 times 2, then that's just x plus 1 plus x plus 1. So that's x plus 1 added by itself. But without this idea of unity, we wouldn't even be able to talk about x. So we see that unity is numeric unity is essential to this kind of understanding. And in matrix multiplication, we see if you consider 2 matrices, A and B, and they have this example is a 2 by 2 matrix, you'll get a result P. And to multiply these matrices, as I showed in the slide earlier, you multiply the rows, the elements to each other and add, and then I'll let you pause to consider the solution for 3 seconds. 1, 2, 3. Okay, and the solution is this. So whether or not you got it, I hope it was fun. And if you had multiplied by the identity matrix, which I encourage you to do as well, if you pause this, you would get the same matrix that you multiplied it by, right? So we see that it's similar to the number 1 in regular numbers. So in conclusion, we have a very intuitive notion of what 1 is. It's really not hard to understand. What is helpful, though, is to formally describe the properties of 1 and the characteristics of 1, which philosophers, in particular Neo-Platonists, have done. And so we can see that it has irreducible simplicity, completeness, indivisibility, and that 1 is implied in other numbers, or that the existence of any number implies also that 1 is a factor of that number. So this philosophy, we saw by the examples, is consistent with our intuition, and so it shows that Neoplatonism at least isn't crazy, right? It seems to make sense philosophically and in practice. But it does raise some serious questions, like those that are listed here, and I hope you will consider them, and I hope you enjoy this video. Thank you.